part 2, question 1, or excuse me, question 6. It says, what are the 3 assumptions that need to be checked before you can compute a confidence interval for a mean?
Okay. You need a simple random sample drawn from a population.
Yes.
The sample mean needs to be normally distributed, and the sigma is assumed to be known, or the standard deviation.
Yes. Okay, the graduate management admission test, the GMAT, is used as an admission criterion in many Masters of Business Administration programs. A BOUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean for the students is 541, assuming a population standard deviation of 32. Answer the following questions. What is the point estimate for the population mean? Should just be 541, isn't it?
Mm-hmm.
Sweet.
You want me to read?
Yeah.
So, create a 95% confidence interval for the population mean. Show all your work below.
So, this is where we use that formula, the point estimator, the population mean. So it'll be 541 plus the z-score of 95%, which is 1.96, right?
Yeah.
And then my calculator.
It would be the 32 over the square root of 50.
.52. So for the high end would be 549.870, and then bottom half would be 532.13. Is that what you got?
Mm-hmm.
Okay, cool.
So in 9 we do the same equation, but n is 100. Instead of 50, right?
Yeah, so this is going to make it narrower, right?
Mm-hmm.
Yeah.
.272.
Mm-hmm. For the bottom one, we got 534.73.
Sweet.
How does the margin of error for the 95% confidence interval of sample size 50 compare to the margin of error for the 95% confidence interval of sample size 100? Note it.
They got like narrow.
Yeah.
Yeah, it gets smaller as the sample size gets bigger. So the more we put in for n, the smaller it's going to be.
So this time it's 90%. So
That's the 1.65 that talked about in the lesson.
yeah, instead of 1.96, right? 1.96 is what we use for the 95, right? Yeah.
Say that again.
I said it twice.
No, I was working on something else.
196 is what we use for the 95%.
Yes. So we take 541 plus.
We got 533.56.
My answer I got's a little bit different than the answer key one. I got 548.47. But it's close. It's close. I don't know what.
Mhm.
My formula is exactly the same. I'm assuming it's. I think it's fine. How does the margin of error for the 95% confidence interval that you computed in your question 8 compare to the margin of error for the 90% confidence interval that you computed in question 11? That one's still larger.
It's the same as number 10.
Well, the 90% got like a little bigger.
Doesn't the margin of error still get smaller?
Yeah. Okay. Next one.
Yeah.
Yeah, the BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval?
5 in for it.
The margin of error is 5. So 1.96 times 32.
Divided by 5. So that means 2.
Okay, I have no clue how to do this.
Okay, so the z squared 1.96.
The standard deviation is 32.
So is it like you work backwards kind of thing?
So n equals.
We're looking for n.
Yeah. So would you still use the 541?
No. Oh. Hold on one second. Okay. So what we do is you take 1.96 times the standard deviation, which is 32, and divide that by 5, and you square it. So you get 157.35.
What's the answer key? The answer key says 158, so I'm guessing you would round up because you can't have a 3-5 person.
Yeah. So, ready to take the quiz?
Yeah. You just figure this out. Pull it up. Oh, how'd you guys do on the test?
I think I got a B.
Good. Me too.
I think it was like an 87 or 88 or something like that.
I think I got like an 86.
Yeah, that's what I got. Isn't that what I got?
Yeah, something like
Okay.
that. Oh.
What I'm wondering is how do we do this without population?
Find the margin of error for a 90% constant interval when standard deviation is 50 and n is 25. So the 90 is the 1.65, right?
Yeah.
Yeah.
So do
This is number 13. Number 13 is different. How do you do that without?
Okay, I got 16.5, but I don't think that's right.
I think you're right.
Really?
Yep. Because you do 1.65 times 50, which is the standard deviation, divided by the square root of 25. So it'd be 120. It'd be 1.65 times 10.
Oh, true.
I think you're right.
Which of the following statements is true? Mu is a point estimator of sample mean. Sigma is an interval estimator of standard deviation squared. Sample mean is a point estimator of mu, or standard deviation squared is an interval estimator of sample mean.
So
Would it be the first one?
Yeah, I think it's.
Because I think that mu and then that x with the bar on top mean like the same thing.
Yeah, but I'm trying to. Which one would it be? That one or is it the third one? I can't remember which one. I think. I think it's the third one
Okay.
because the. Yeah, I'm pretty sure it's the third one.
Let me see if that ring.
Yeah, I think so.
Okay. Who's that, Gina? Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a random sample of size n equals 64 and computes the sample to 526. What is the lower limit of the confidence interval?
No, okay.
I got 498.315. Mm-hmm. Is that what you got too?
Almost done with it.
498.
Okay. What did you say that?
498.315.
That's what I got.
Sweet.
So would we put 498?
No, it says round to the 3.
Oh yeah. Sorry, I have like a stomach bug, so I'm just like out of it right now.
No
I'm
worries.
sorry.
Okay. Hanging around kids too much. Okay, I got 553.685.
That's I should remember how to do that. 553.685 that you said?
Yeah.
That's what we got.
Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
It decreased.
Yeah.
What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
Did it increase?
Yeah.
Okay. Brightfield Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
Okay, so this is when we do the very end. You take the It's 1.96 times 400 divided by, you said 50?
50 hours, yeah.
So would that be like 16?
We got 245, so it would be 246, I think. So take 1.96 times 400 divided by, divided by 50, and then you square it.
Oh,
The 2
The mean salary of actuaries is 100,000, and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level of significance of 0.05. You collect simple random sample of 36 women's salaries to find the X, and the number is 111,000. Use information to answer questions 10 through 12. What is the lower limit of this 95% confidence interval?
so 95% is the 1.96, right?
Yeah.
Yeah.
So is the level of significance, is that the same as the standard deviation? No, excuse me. Hold on. Look at the formula. So we need to find I'm just confused because of that.
Okay, I got 99,002.
Yeah. So the upper limit would be
Yeah, 122,000. Right?
yeah.
198.
No.
Right.
If you ran up the nearest whole number. So for the other one, still think you ran that. For the next one, did you get 120,998.4667?
What?
For the next one, for number 11, the upper limit, did you get 122,999.467?
Yeah.
Or 198,000, excuse me. So do you think we round up to 190 or 120,999, or do you think you round down to 998?
I think you round up.
That's what I think too.
Okay. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: a simple random sample was drawn from the population, the sample mean is normally distributed, the standard deviation is known, or all of the above.
All of the above.
All right, ready? Oh, and then on number 3, do you think we need to round to 16.5? Like we had our, it says round to the nearest 3. Do you think we need to go to 16.500?
Yeah, do the 0, 0.
That's what we did, yeah. So the only one we missed is number 3.
But we tried 16.5 and that was still wrong, so. Yeah.
Well, we got a 92, so that's good.
I'll take it.
Good job.
Thanks, you too. So we'll see you Thursday.
Yep.
Sounds good.
Get feeling better.
Yeah.